Okay, this one is actually question 12b. They want to find a resolution. Sorry, they ask you if electron were used, calculate the minimum kinetic energy required for the electron to have a resolution approximately 1 times 10 negative 11. So basically, you want to have lambda at least 1 times 10 negative 11. So we want to calculate when lambda is this values lah. So we want to relate with the kinetic energy. Okay, so the given equation in the formula sheet is lambda equals to h over square root of 2 MeV, but you can substitute EV with kinetic energy, right? So it becomes 2mk. So lambda is 1 times 10 negative 11. Planck constant is 6.63 times 10 negative 34 square root of 2, because this one is electron, so you have to use mass of electron, which is 9.11 times 10 negative 31, and we want to find the k. Okay, so if you're not sure how to solve this one, you might have to do one by one lah. So if we calculate, I got kinetic energy k, which is equals to 2.41 times 10 negative 15 joule. And then question number 2, B2, if photons were used instead of electron, calculate the minimum photon energy needed to obtain 1 times 10 negative 11. So presume that you can get that particular wavelength. They want to find the energy. So E for photon is equals to hc over lambda. And then remember, the energy here is basically the kinetic energy lah. So it will be 6.63 times 10 negative 34, 3 times 10 to the power of 8. This is the speed of light, divided by the required lambda, which is 1 times 10 negative 11. This one is 1.99 times 10 negative 14 joule. For question 14a, they want to find wavelength, calculate the electron to photon ratio of their wavelength if an electron and photon has the same energy. So they want to compare what if electron and photon has the same energy, and they want to calculate their ratio. Okay, so for electron, start with electron first. So you know that lambda is equal to h over square root of 2 MeV. I told you that you can write this one in terms of k, right? And at the same time, if U is equals to K, and I mean if there's only one types of energy, then H is equals to square root of 2ME. This is just a symbol. This is is energy, are energies. So for this one is for electron. Okay, so the mass will be mass of electron. For photon, you know that lambda is equals to E is equals to hc over lambda, right? So hc over E, rearrange, it becomes like this: electron, photons. So their ratio, electron to photon, so basically lambda E over lambda will be h over square root of 2MeE. And then again, you can substitute the values if you want to. I mean, you can substitute the values of E, but I prefer to cancel out first. E is given to EV. So I can cancel out the H, or maybe I can rearrange this one. Becomes, I leave the above here as it is, and then because this one is division, so I just put it upside down. It comes like this. Okay, I can cancel out the H, and this one is E half, that one is E, so it becomes E to the power, this one E to the power of 1, this one E to the power of half actually, so 1 minus half is half, so you left it square root of E over C square root of 2ME. Now you just have to press your calculator. Square root of 2EV, if you change to joule, then it will be 1.6 times 10 negative 19, because you have constant C there, so you have everything, you have to use SI unit. Mass of electron is 9.11 times 10 negative 31. So I got here is 1.3969, or if I round it off, it becomes 1.40 times 10 negative 3. Ratio, there's no unit. Okay, and then question B, they want you to find the ratio for speed. Okay, so speed of light is c times 10 negative 30, 3 times 10 to the power of 8. That one is a constant. Just want to find question for speed of electron first. Okay, so you know that U is equals to K. So U here is basically the energy lah, E, which is 2 EV. K is equals to a half mv square. So that one is mass of electron, because we are talking about electron. Okay, so V here would be 2 E over mass of electron, and take the square root. Therefore, ratio of electron velocity over photon times 10 to the power of 8. That one you just C. We'll leave it in C first. The square root of 2 times E is, sorry, you have 2 EV, right? So 2 times 2 times 1.6 times 10 negative 19. So again, you have to convert EV to joule. The mass of electron is 9.11 times 10 negative 31. C is 3 times 10 to the power of 8. You can bring C to the other side. I mean, it becomes I try to solve this one. Okay, so I will get 2.794. So VE over velocity of electron, the ratio of electron velocity over photon velocity, so actually equals to 2.79 times 10 to the power of negative 3. Okay, again, there's no unit. Okay, question number 15, electron and proton ME and MP separated from rest by the same potential difference, so V is the same. Find the ratio of d Broglie wavelength for the electron, lambda E and lambda P. So maybe you want to relate something, an equation that has lambda, V and mass. So I think on top of my head would be lambda equals to H over square root of 2MEV. Okay, so if you are talking about lambda P, so straight away you can find a ratio lambda E over lambda P. So lambda E over lambda P for electron, it would be H over square root of mass of electron, constant E, and voltage V over 2 mass of proton, constant E, and then V. I can rearrange this one. I mean, you can cancel out straight away, but I just want to rearrange so that you can see it better. And then remember, square root, you can separate it into a different, like multiply like this. Okay, I just want to show you how to cancel it out. So division, you can change to multiplication, but you have to put it upside down, so it becomes square root of 2 square root of MP square root of E square root of V, capital V, over H. Cancel out the H, square root of 2 cancel out, constant E, constant V, this V is the same, so lambda E over lambda P is equals to square root of MP over ME. Okay, so they want you to find the final answer in terms of ME and MP, so you really don't have to do anything. You can leave it like